Well, hello everyone. Welcome. This is the Bleeding Edge HTML5 talk. My name's Paul Kinlan. I'm a developer advocate at Google. I work on the Chrome team. I'm part of the Chrome engineering team as well. And today I'm here just to talk about kind of the latest and greatest in HTML5. It actually is a relatively small subset of the entirety of all the new APIs that are coming into Chrome. But we're going to talk about things like the file APIs, web intents, and kind of a whole load of other really cool stuff. But yeah, so this is me. I'm on Google+. I've actually got Google+ open. If anyone wants to ping any questions via that, we'll check at the end. I'm on Twitter, and that's my blog as well. But like I said, I work at Google, Chrome developer advocate. So the agenda for today is to talk about building kind of intelligent web apps, basically taking advantage of the latest kind of platform features that are coming into the browser, and then how to make your applications kind of, I suppose I'm going to say look beautiful, but actually use things like the full screen APIs. We're going to talk about web audio and the real-time communication stuff that's going to land pretty soon. So let's get started with intelligent web apps. The whole idea behind intelligent web apps is that we want to make applications which are a bit more responsive to the state of the device, and things like if we know, for instance, that the user's not looking at a page, we can kind of throttle back the amount of work that the browser does. And one of these things is the smarter animations. This whole idea of using let's have a zoom in so we can see it a little bit better. Ooh, there we are, window.request animation frame. The whole idea behind this is when you're building games which are, they tend to be high performance, 60 frames a second, the old style set timeout, it doesn't work very well. And even when it does work, it never stops. So the whole idea behind some of these APIs, if you're not actually playing the game, the set timeout will still fire, your game will still run in the background, and it's never actually really capped at any particular level as well. So one of the things that we're trying to do to make applications and games be a bit more responsive to the user's hardware at least is this whole idea of animation frame or request animation frame. And all this is, it's one API call. Let me zoom out again. It's essentially one API call that you keep calling to say to the browser, I'm ready for you to draw a new page or a new frame in my game. Just draw it whenever possible. And there's a couple of nice things that Chrome can do. Chrome kind of caps its sampling rate to 60 frames a second. It'll always try and be 60 frames a second. If your logic inside this callback here takes longer, then obviously it's not going to be 60 frames a second, but we're pretty much kind of synced to the actual monitor kind of refresh rate. And then the other really cool thing about this is that because we're asking the browser to say to the browser when we can update the next frame and when our logic can be called again, the logic inside here, we can do nice things like pause the game. So if you're not actually on a tab, and for instance, say you went away, the whole theory behind it is that your game will pause. And this is because the browser itself knows whether the user is actually watching the page or using the game or not. It's kind of a nice way of actually doing smarter animations, nicer game control. It's a relatively simple API. It's relatively low impact. And it works across a whole kind of range of browsers, and we've got the code there as well. This is the example. It's not a great demo. We've got set timeout, which we're saying is 10 milliseconds. We've got a kind of 91 hertz. This kind of is a bit weird, this demo. And as you can see, this one is capped to about 60. But the code pretty much is exactly the same. The whole idea behind this, though, is that in theory, if we go here and kind of come back, in theory, what would have happened in the background is that actual animation frame would have paused. It's kind of simple, it's kind of easy, and it's for controlling things like animations in your games and all that type of stuff. It's just a nice little API to make your application a little bit more intelligent. Page visibility. Has anyone seen this API? The page visibility API? One person, two, three, couple of people. It's kind of interesting, the visibility API, because it actually lets us, let's do the demo. It actually lets us get an event delivered to our application that tells us, the user is not looking at the page anymore. You might want to pause some kind of videos and all this type of stuff. And then it'll send an event back to say, hey, look, the user has come back to your page. Go ahead and, play the video again. And we've got a nice little demo here, which is we probably can't hear that, but the demo is it's a video, it's playing. We'll jump to another page. The audio stops. The actual video has stopped itself. If we look at there, it's still at 6 seconds. We jump back and it starts playing again. It's just kind of a nice little use of the API. And it's one of those APIs that we've never had on the web platform before. And it's kind of interesting. I don't know where it's going to be used, but where one thing that I kind of can see happening is kind of advertisers using it, because if you're not looking at the advert, there's no point playing the whole kind of animation. It's kind of good for games because you can obviously tell the user, hey, welcome back, and all this type of stuff, but also then make sure you stop the other kind of logic that you might run at the same time. And then we've got the ability to pre-render pages. Has anyone seen the pre-rendering? One person? Hey. He's a Googler, so he's probably seen it. The whole idea behind the pre-render stuff is we can actually use this very basic piece of code here, link rel, to actually indicate to the browser that basically the pages that we think the user might most likely go through the next, their next action. We're basically trying to preempt that. And the whole idea behind this is that actually the browser will then go and pre-cache the page behind the scenes. It'll pre-cache the page behind the scenes, so when the user clicks on that link, it'll be nearly instantly available. That's the whole theory behind this API, is we want to make it really quick, the whole kind of navigation experience really quick. And if we can pre-render some assets, then we can. Let's try this demo. This demo never, here we go. Pre-render is disabled. Bad demo, I apologize. Okay, cool. So when we're trying to build applications that are a little bit more intelligent, one of the biggest things that we face is actually knowing when you're online. We had a talk earlier today about actually making your applications work offline. And to me, this is one of the really biggest things about what we can do in the web today, is obviously we've got app cache, so we can make our applications work even when we've got intermittent connections, no connections at all. But we want to let the user know whether the page, whether the actions that they're going to do will potentially succeed against the server. So Mozilla have had this API in for a while. I believe it's been in Safari on the iPhone for quite a while, but the whole idea behind this is we have basically an object which we can inspect, navigator.online, which tells us whether we are online or not. The way it kind of works is it doesn't work completely as you might expect. It works in the sense that if the network interface is up, you're pretty much going to be online. It won't check to see whether you've got a completely valid internet connection, because all it really knows is it can reach a network, and that's kind of fine. So it doesn't work if maybe you're on kind of this hotel network and you're not completely registered. You actually haven't got access to the internet, but technically you're online because your network interface is up. But we also get a nice kind of set of events as well. So we've got these events here, window.add event listener online and offline. And basically, they just get fired when that network state changes. It's kind of a nice API. It's kind of cool. And the really cool thing is that you can just basically say to the user, the action that you tried to do probably won't work. It's just one way of making your application a little bit more intelligent. And this is the demo. Should we try this? This might completely fail. I'll go offline. Turn off. And what we should see, hey, there we are. So that was just a basic event. It was a JavaScript event that we listened to see whether we're online or offline. And in this case, we turned off the network interface, and we were just told inside our application. It's pretty cool. Turn it back on. Hey, let's have a look. I'm connected to the right network. It's kind of cool. Okay, so cool. And that's all it was. It wasn't anything more complex. It was just that one little event listener. But again, it's one of those things that, the old way of doing this would you would try and send off an XML HTTP request and then check to see if it failed, if it timed out, and a whole load of other things. It's kind of not an amazingly reliable way of checking for online presence. And this is a lot better. Oh, let me just click on this. Right, I'm going to use the keyboard. Cool. Okay, so for intelligent applications, has anyone heard of web intents? Hey, cool. So I've got a nice little story about web intents that I hope people will like. It was actually this time last year at the GDD. Who was at the GDD here last year? Quite a few people, cool. So I was on the plane from Moscow to here, where we were thinking, well, what can we do? What cool things can we do on the web? What can we think we can do in the JavaScript emulation, And one of the things that we really wanted to do, we really liked the whole idea behind Android intents. And we just basically said, I think we can actually build an intent system for the web We basically just thought we could build it. I got to my hotel, this hotel. I registered the domain name for webintents.com and .org. And WebIntents was born pretty much a year ago today. Well, a year ago, give or take a month. But it's kind of cool. So what is WebIntents, right? So the whole idea behind WebIntents is we have this kind of weird problem on the web where we've got a whole series of APIs which are, they're amazing APIs, right? They're really good. But if you're a developer and you want to build an application which is responsive, uses a bookmarking service, for instance, this is an example here. We've got 30 different APIs that just do bookmarking. And if you're not familiar with kind of bookmarking APIs, the kind of the state of the industry inside bookmarking, how do you know whether you should choose Bibsonomy or Blue Dot or GroupMe, any one of those different services? How do you know which one you should integrate? You end up having to do a whole lot of research. So you might choose the most popular ones. You'll find that Delicious, whatever it is the most popular service that people use. So you'll integrate with their API. Then you might choose GroupMe or Historious or Instapaper and all these different services. But then, you've integrated 3 different services or 4 different services. You've spent a whole amount of effort just to build, your API integration into these. And then you get a whole load of users who will say, well, I don't use any of those services. Can you integrate me with, Magnolia? I mean, Magnolia doesn't exist anymore, I don't think. But can you integrate me with Magnolia? And then you have to either decide whether it's worthwhile. Have you got enough users who use Magnolia? All these type of things. It's an absolute nightmare for you to try and do. And then also, if we get to this point where Magnolia disappears off the face of the web, what do? Do you have to remove your code? There's a whole load of problems with this. And this is one of the things that we want to try and solve, right? And this whole idea is that this dude is frustrated because he's a user and you don't support his services, right? He wants to kind of get this whole, he wants to use Magnolia, you don't support it. He wants to use Delicious, you don't support it. This is the trouble he has, right? And it's the same for things like Gmail, right? Gmail has got, integrations to like Google Docs and Calendar because we own them and we've got good integrations with them. But what happens if you use Tungle.me, or kind of any other different external calendaring service, right? Are we going to integrate with it? I don't know. The answer is probably no. But you want to use those services because that's the service that you use, right? So just imagine that you're the developer of a service. And this is actually, did anyone use FriendFeed at all? No one? Okay, cool. So FriendFeed was one of my kind of really favorite services for aggregating all kind of social content from around the web. And this is the problem that you as a developer face. If you want to integrate with services, you have to try and integrate with every single service that's on the web that maybe pulls in data or that you use. It's nearly impossible, right? There's probably about 80 or 90 different services that FriendFeed used. And I think I was one of the power users on FriendFeed. I had probably about 10 or 12. So that means kind of like 15% of the services that, I only use 15% of the services, 15% of the work that FriendFeed put in to integrate with all these APIs. And that's just not feasible, right? I mean, you as a developer, that's just, trying to repeat this isn't kind of feasible at all. And this is why he's really, really depressed, is because he's also a developer. You thought it was a bit too much before, but now you understand. The whole point of this is it's really hard for users and developers to actually use the services that they want to use for applications, at least. So what are web intents? Web intents, the dictionary definition is a bit dry, but web intents is a framework for client-side discovery and inter-application communication. And actually what that means is it's basically a client doesn't have to know about a service application, and a service application doesn't have to know about a client application. Yet they can both discover each other and talk to each other, right? So this is how it works, basically. The service registers its intention to handle an action for the user. So it might register its ability to do a share action or an edit image or maybe pick a file, like a pick file from the internet kind of action. And that's all it has to do, really. The client application will then request a list of, basically, it will request a list of applications that support the action that it wants to complete. So you might have an application which says, I need to find all the services that can support image sharing, and then the browser will handle the rest. It will give you the list of applications. Well, I say give the user the list of applications that they've installed that can handle image sharing, but it won't give you a list of applications that support, I don't know, image editing. It's got like a nice little filter system. The user selects the service that they wish to handle, and that is pretty much it, right? If it sounds familiar, does everyone use Android? practical, right? We're all actually probably quite familiar with this in the sense that the actual intent system is completely hidden from the user. They don't know about an intent. They don't really care what an intent is, but they can be in their browser, press the share button, and then up pops a list of all the applications that can handle that share action. And like I said, if it sounds familiar, it's kind of pretty much copied from the Android intent system. We absolutely love the way that works, and we want to bring that to the web. So yeah, if you're familiar with that, which I think most people will be, then you'll see it here. Well, you'll see how it's kind of similar. So actually, how do you register a service application with web intents? Well, it's relatively contentious, but the idea is behind this is we've got an intent tag. The intent tag is there because it's declarative. We didn't think we needed a JavaScript API for a declarative method. And we can do really cool things with search engines and other applications. We can index a list of all the applications and sites that support specific actions. If it was a JavaScript API, it'd be very unlikely that we could do that easily. But anyway, you have an intent tag. The intent tag basically has a couple of properties. Most of them are optional. The only one that is required is the action. Now, the action, it looks like it's pointing to a website. It's not. It's just an arbitrary string, but it's namespaced. So what we're saying here is that this intent, this application that has registered this intent, will support image sharing, or sharing, basically. But we then filter it out by saying, actually, this application will only ever support image sharing. So it's kind of cool. It's kind of interesting. This namespace here doesn't have to be webintents.org. It could be the word, I don't know, twitter.com/retweet. It could be any different type of service available. It is just a string that is part of filter match. It's kind of interesting how this is going to work. And then one of the final parameters, at least, is href. It's optional. Href is just a link to the actual page that you want to open, that you want the user to open, at least. So if it was, if you ignore it, it's the current page. If you specify it, it just opens up another page. It's restricted to the current domain, so you can't go and open twitter.com just from your own site, but it's kind of powerful, kind of interesting. And then the client, right? So you're a client application. You want to integrate with sharing services, or maybe like an image editing service. In this example, it's a share service. This is the code that you have to do. It's actually changed this last week. It's all inside the intent tag now, but the idea is that you construct an intent object. You tell it the action that you need. So in this case, I need the share action. You tell it the data type you want. I'm saying that I want any application that can support image sharing. And then you give it the data. The data here is an array. It's actually changed again this week. But the idea behind this is the data can be the physical raw data. So it can be the binary data. It can be a data URI if you want as well. Or a URI to some remote image hosted on some other service. So it doesn't actually matter how you actually encode the data getting in, as long as the client application can understand how to decode it. But what you're saying is you're going to deliver the service application an image, and then they parse that from there. But essentially, it's window.navigator start activity with the intent object, and that is actually pretty much all that you do. When you're the service application and then your application has been invoked by the intent system, you kind of want to get that data back out of the system. So there's a window where there's a global object called intent, and the data is encoded inside the .data, basically the data property inside the intent object. And that actually is it. We've actually integrated two services. That's pretty much all the code that you need to build an application which can basically request, or build an application that can request services from another application, or build an application which can receive data from another application. It is pretty much just kind of one line of code, and then you take the data out, and you might still do more kind of things to construct your DOM and all that type of stuff, but that's essentially the basics of it. But we can do quite a bit more than that. It would be pretty rubbish if we could only send data one way. It's kind of cool that we could maybe send a link to Twitter or a link to any other kind of sharing service or maybe an image. But actually what we want to be able to do is we want to be able to pull data back into our application. This is really powerful when you think about kind of a pick intent. So the idea behind pick is that you might want to say, I need to find a service which can let me select an image. And this is really powerful when you think of things like Gmail, which has got a file upload button, where you actually pull the file from your local file system and then upload it. And if you've got a service, well, say all your images are hosted on Flickr or some other remote service, the kind of current user flow, the user experience is that the user would have to go to Flickr, download the image, store it on their hard drive, jump back to the Gmail application, open the file picker, find that file, upload it into their application, and then send it on. And what we're saying with things like pick is actually if a service can let you pick files off the internet, then you can just pull that file directly into your application. You don't have to do that whole intermediate step of download the file and then upload the file back to the service. It's just pulled directly from the service. It's kind of a nice way of doing it. And actually, this is the code. This is pretty much all the code that you need to pull an image in from another service. So this one is saying, I need to pick an image. So we select this. Sorry, it's pick. An image. I need to pick an image from somewhere. I don't know where it is. I don't particularly care where it is. It's all down to the user's choice of kind of service provider. And then just let me know when the data, it's this bit here, just let me know when the data is available. So essentially we start an activity with a callback, and the callback is invoked when the user has completed their action inside that remote application. And in this case, all we would do is just basically attach the image to an image source element. And then we post the result back. Well, if we're a service application, all we have to do is post the result back. And if we call post result with some data, then this function gets called. And it really is kind of that simple. And I've got a little demo in a minute, which I hope is going to highlight the power of this API. Oh, there we are. Sorry. This started working. I can't believe it. OK, so this is the demo app, right? It's a nice demo application. The thing I want to try and highlight about this is really, so here we are. So this is the start. Right. It's 43 lines of code. And most of those lines of code are either padding or like exposition, basically, just things that don't need to be there. So it's 40 lines of code, and we've built, basically I'm going to show you the complete application that we've built. It's kind of cool. So the idea behind this, at least, is that this is a meme service. We want an image, we want to attach some funny comment to a picture of a kitten, and then we want to try and share it out to Twitter or something. So it's kind of cool. So we built that in 40 lines of code. It's really good. So we got this idea of, we'll say, oh, sorry, I'll start again. We'll say choose image. This actually starts the pick of type image. And then it's listed the services that I have registered that can handle that image type. We've got a nice one, which is kittens. This is my fallback one, right? So we can pick a kitten. It's called a kitten picker. It's kind of cool. But actually, the interesting one, which is why, if you were watching my screen before, you saw me log into email, is Google actually built a cloud file picker system maybe about 3 or 4 months ago. It was a JavaScript API, which allows you to pull in files from, say, Picasa, Google Docs, Google Image Search, and it allows you to do a whole load of things. And with our API, we've actually integrated the Google Image Picker or the Google Cloud File Picker into the web intent system, even though the Google Cloud File Picker guys, they don't particularly understand web intent, or not understand it, but they don't particularly have time to implement web intents at the moment. So the really cool thing about this is, even if you've got third-party access to, say, Facebook, Twitter, all these extra different services, even if they don't integrate with the web intents, you can actually still build that integration for them and provide that service. And this is exactly what we've done. So let's have a look. Picture of me. I'm vain. There we go. Pull it in. So basically, I've pulled in my picture from Picasa in my private file store directly into my application. It's kind of interesting. We can't really do much with it unless we edit it. So I'll press edit. This is a list of services, only one service, which can handle edit image. So I'll press go. There we are. So what's happened now is I've taken the image data from Picasa, pulled it into my application, and then pushed it into this other application, which is, like I say, an image editing. It doesn't do much image editing. It's pretty rubbish, but we can do hello Prague. There we are. There we are. It's kind of cool. I press done editing. It takes 5 seconds because of a bug that I introduced through the week. But there we go. So this is our application again. So this is kind of 2 steps in that process, which is the 2 intent handlers. We've picked the image, pulled it into our application. We've said, oh, we need to really do something cool with this image. We've pushed it out to an image editing application, saved it, pulled it back in, and now we've got this kind of image inside our application. And then we have the ability to do kind of, something cool. We can save it, share. I'll just pick save for now. So this is kind of interesting, right? I kind of want to see people like Dropbox and kind of Box.net and all those kind of cloud-based file solutions integrate with web intents, because you might have a file on that system which you want to pick and pull into your, say, your email client. But then at the same time, you kind of want to save that same file. If you do some edits to it, save it back out to the cloud file system. So I developed a cloud file system storage system. It's actually on localhost. It's a Google App Engine project. You have to believe me, this works. So what's happened now is it's basically pushed it into Kinlan's file store, K3. Nothing kind of inspired by Amazon, but here we go. Let's have a look. Just to prove it works. Hey, cool. So that's the file. Oh, there we are. You can't see the binary data, but you have to trust me that this database was completely empty before, and it's actually basically saved the file to this other remote web system. So just imagine Kinlan's file store K3 was Amazon S3 or Box.net or anything that you want to use to save files. We've actually just integrated with no more than a small piece of JavaScript. All the authentication is done because you're a web user and you're actually already authenticated with Box.net. We're not trying to do any kind of weird OAuth or OpenID kind of things at all. We don't need to. But yeah, we've built an application which, in 40 lines of code, can pull an image in, edit it, save it, or share it. It's kind of cool. It's kind of powerful, I think. But yeah, that's kind of cool. So that was the demo app. And that's kind of the end of web intents, at least. The whole idea behind that is we are actually building this into Chrome at the moment. We're trying to work with people like Mozilla as well to actually get this to be a non-browser specific API. It's going to be really important. But the interesting thing is we didn't actually get this ready. Sorry about this. We actually have a full API implementation ready on GitHub. But it's all done in JavaScript. So the idea is that you can actually drop just the JavaScript shim into your page. And it's intelligent to know that when Chrome actually physically or natively implements this, to kind of let all the functionality be deferred to the native implementation. But you drop this JavaScript into your page, and then you'll get the kind of the JavaScript shim, the exact piece of functionality that we've just seen inside our application will be available. When the native application or the native functionality comes out, then it'll just be replaced by that. But today it's available, and it's on github.com, Paul Kinlan/webintents. And I'll tweet that later as well. So yeah, that's the end of web intents at least. When we're building kind of cool applications, we want to have, I suppose one of the biggest things that we've never had on the web is really rich multimedia without a lot of third-party plugins. But that's kind of starting to change on the web now. It's kind of interesting. The first is camera and microphone access. I mean, this is going to land pretty soon. It's not quite ready inside Chrome. The API has been pretty much spec'd out, but essentially it's just this piece of code here. It's kind of cool. So we issue a command called window.navigator.getUserMedia. And in this case, we're going to say video to get access to the webcam. And once we do that, we can actually get a URL to kind of the webcam stream, and then we can attach it to a video element. So that actually means what happens is you get the video data, you get the URL for it, you attach it to a canvas, attach it to a video, sorry. Your videos don't have to be visible, so if you want to kind of do some really nice effects with canvas and all that type of stuff, it's really easy to actually embed a video on a canvas, and then you can do like grayscale effects and kind of a whole load of really cool things, just in straight JavaScript, no plugins required. And it's kind of interesting because you can also do things like get the recorded data. So it's not just about kind of getting the live stream of the video camera and then manipulating it, and that's kind of it. You can actually say, you can get the recorder by starting the record. So it's this function here, and then you can stop it when you're finished, and then you can get physical access to the raw binary data of the data that was generated by the webcam. And then you could do something kind of cool, like take your XML HTTP request and then upload that to the server. It's really pretty cool. The interesting thing to note, this isn't the real-time communication stuff, which we're going to talk a little bit more about in a minute. But this is going to be one of those things that starts to change the way we build applications on the web. It's a really nice API. Full screen. Has anyone seen the full screen stuff yet? Well, you probably have, but the full screen is one of those things that Flash has kind of always been able to do. And the browser itself, using kind of, at least in this, which is the kind of presentation mode, has always been able to go into full screen. But now we have the ability, using a very simple API, to take pretty much any DOM element and make that full screen. So you can take a video control, an image, a div, all those type of block elements. You can basically just say, this is going to be full screen, and you can do it that way. And this is it. This is the API call actually here. The element, which is you could either be the full body, it could be the video element, it could be the canvas, it could be the image, any type of element that you want. You call WebKit request full screen, and then you go full screen. So let's have a quick look. Yes? Yeah, pretty much. So the whole idea behind it as well is it's only invoked by a user action as well. So you can't automatically kind of go full screen. So you can't have like a page that does like a drive-by full screen and makes it all kind of crazy. But yeah, you can open it up and then you should be able to, it's the same thing. You should be able to press escape and then get back out of it. I actually have never tried an input element. You might be able to. We could try it if you want. This is the demo I've got. This is just a normal video embedded in a normal HTML document. It's kind of simple, kind of plain. But we can toggle full screen mode. So actually what we've seen is... oh, sorry. There we are, sorry. My escape button didn't work. I'm already in full screen mode. But the idea is it's this div here, which we're making full screen. So you make it like a full screen movie player. It's kind of powerful. And I say it's powerful. It's powerful because it's really simple. It's that one call. But then you can also listen as well. So you might want to change the user interface, whether it's full screen or not. So you can also do things like listen to an event for in this case, it's WebKit prefixed. So we have to, it's not going to work. It's not going to work in Firefox just this way. But we can listen to those changes. We can listen to the change of the state, and then maybe just kind of do an alert or kind of whole load of other stuff. But there's a bit more to the API. You can detect whether the actual screen whether it's in full screen, whether the element that you're manipulating at the moment is the element that made it full screen. Actually, you can also cancel it. I didn't actually realize that it existed. But the really interesting thing is we've got pseudo classes as well in CSS. So you can actually, excuse me, you can actually restyle your page and provide different CSS styles based on whether that element is in full screen or not. It's kind of nice. It's kind of simple, and it's going to be interesting to see the types of applications that come out. I believe the first ones are going to be video player applications and games. Canvas games. You make the canvas full screen. Yeah. So WebRTC. Has anyone heard of WebRTC? Yeah, good few people, right? This for me is going to completely change the way that the way that we kind of work on the web, and it's really, really powerful. So there is this huge demand for real-time communication, being able to kind of have face-to-face camera, video, audio, and all this type of stuff with the people kind of inside your application. It's big. I can't say it's ready. It's not quite ready yet. I hope it's going to be ready soon. But the really important thing behind this is that it's going to be enabled without any plugins at all. So if you actually look at some of the work that Motorola have done, I think it's Motorola. Yeah, pretty sure it's Motorola, or Sony Ericsson. Sony Ericsson, sorry. They've basically done a patched version of WebKit, which has got the real-time communication APIs in. And essentially, you can send someone else's video camera straight to a video element. And because it's a video element, you can do any CSS magic that you wanted to do on it. It's really cool, some of the stuff that you can do. And it's all without third-party plugins. It's all built straight into the browser. So because it's built into the browser, the browser needs to do a whole load of things like echo cancellation, noise reduction, kind of volume control. So if you start shouting into the microphone, it kind of reduces the input ranges. And then it'll also manage kind of the peer-to-peer connections and network latency and the whole kind of range of those type of problems that you face. And the reason why it does that is because you need the API to be amazingly simple. We've already seen the kind of the audio-video capture playback and device management because of the requesting the user stream. But there's a new API called Peer Connection API, which is going to start to enable you to do peer-to-peer connections between users inside your application. And the really cool thing about, well, we'll talk about why it's really cool in a minute, but it breaks this whole idea of you having to dial a number to go and speak to someone. It could just be a random Twitter, if Twitter decided to integrate it or whatever, it'd just be, you'd address the user with the Twitter address and then it'll all start up that way. That's pretty cool. But this is the screenshot, which doesn't tell us an amazing amount about how it's actually built. But the whole idea is that there's actually a whole series of APIs and abstractions around the different video encoded engines that it needs to use, the different potentially transport mechanisms that it has to use to actually set up the connections. And that's going to be all abstracted away from you, because as developers, and you don't really need to have to worry about, you don't actually want to have to worry about actually having to manage network connections, latency management, and kind of audio control and all that type of stuff. So you're just going to have a really simple API to start this thing off. And it's going to be really cool, right? I mean, like we said, it's going to break the dial paradigm. This whole idea of dialing a number or physically dialing someone is that, we're going to get kind of, like the way I kind of like it is that some of the really cool things that Google Hangouts have done, it's going to be available to everyone inside their applications to do whatever they want to do inside their own space. It's like build interactive commerce. The idea of actually talking to someone, on the other end of, like, whether it's a car that you're buying off the web or something, actually talking to one of the salespeople, or if it's actually talking to someone at Amazon.com about your broken Kindle, all those type of things. It's kind of pretty cool. Online gaming, I actually see online gaming as one of those ones that are going to start to use it pretty much straight away. Is because you look at the kind of the stuff that Xbox Live has done with party chat and kind of all that type of stuff. It's going to be absolutely cool. Yeah, so it's a community effort. There's pretty much all the browsers that I know of at the moment, so Opera, Firefox, and Chrome with WebKit as well, kind of agreed to support this and actually build it in. Once that happens, it's going to be a massive game changer on the web. Web audio. So has anyone messed around with Web Audio API? One person? Okay. Web Audio API is really cool, and the reason why it's cool is we have audio on the web. We have the audio tag already, but it's just designed to play basic files. It's not designed to allow you to kind of do some crazy things with it. You can't really get access to the audio data. It's not low latency, so you can't really use it inside games. So if you've got like a game, I mean, you look at Angry Birds, it uses Flash for audio. That's because Flash has got like a low latency API. It's not designed to be low latency. We can't do any real-time processing analysis, and we definitely, because we haven't got access to the data, we can't do some really cool effects with it. And the whole idea behind the audio API or the web audio API is that for every single one of those problems we face at the moment, we want to be able to do some really cool stuff. So actually, this is it, right? Have we got audio? Yeah, cool. Sorry. Last time I did this in a presentation in Sweden, my machine completely broke. Because the video camera. There we are. Cool. Good. So the whole idea behind the audio API, it's basically a connection of audio buffers. It kind of looks a little bit complex to start off with. It's definitely not as easy as the audio tag, but it's kind of powerful. So you create a buffer source. So it's this kind of line of code here. And the idea behind a buffer source, that's where you get the data from, MP3 file from the web, local storage, all those type of things. And then you connect it to a destination. You connect it to another node. That other node could be some kind of advanced form of audio manipulation. Maybe it could be some audio processing so that you can show some kind of equalizer graphs. But in this case, it's just the destination. And the destination for us really is just the speakers. So to play the note immediately, or play the sound immediately, you call note on the millisecond delay. And this is impressive, this demo. That's it. It's kind of cool. But then you can do things like you delay by 2 seconds. Here we go. It's kind of interesting, right? That by itself is not the greatest demo. But the whole idea behind this is it's a really low latency API. So if you're starting to build games and you want kind of rich audio, you probably need to use this because there is millisecond delay rather than a 250 millisecond delay between actually telling it to play and it starting. Yeah, this is the interesting thing, right? Is that we can build. Here we are. So create analyzer. So create analyzer is kind of interesting because what you can do with an analyzer is actually get access to the raw data that's in the audio stream, and all you do is you connect. So we got the buffer source here. We connect it to an analyzer, and then we connect the analyzer to the destination. So we've created kind of 3 nodes. We've created the source that goes into the analyzer, which then goes to the speakers. And once you've got the analyzer, we have to assume that it's doing something really cool. So draw byte data. But the idea is that you can actually get the analyzer data, get the byte frequency data for that current timestamp. You get it, and then you can do some really nice kind of animations with it. So hopefully, the next demo will work. Was anyone at Google I/O? Did anyone see this? Oh, it's a new demo then. Oh, wow.
Good afternoon, gentlemen and ladies.
So there we go.
I am a GAL 9000 computer.
Yeah.
I became operational at the Googleplex in Mountain View, California on the 4th of May, 2011.
Yeah.
My instructor was Eric Schmidt, and he taught me how to sing a song.
There we go.
If you'd like to hear it, I can sing it for you. Just what do you think you're doing, Eric?
Cool. So this is actually a kind of cool demo, right?
think
Because I'm hoping that you can. The lighting's a little bit off, so it's hard to see. But actually, inside this kind of red eye bit, we've got the time series data. So we're doing some really cool stuff with this. Basically, it's like an MP3 file that we pulled off the web. We're analyzing it. We're adjusting the kind of the frequency and the depth of the red, so it looks like it's flickering a little bit. And then we've also got the ability to actually analyze the pure time series data and do some nice animations. And this is really powerful, right? It's a nice, beautiful demo, which was completely impossible on the web. It's hard to actually explain in any other way than it was impossible on the web to do unless you used Flash. We're actually pretty much at the end right now. I'm hoping we've got time. So yeah, we're pretty much at the end. I have no idea whose dog that is. We just had a dog. If you want to kind of learn updates about Chrome, we've got chromestatus.com. The whole idea behind Chrome Status, it's like caniuse.com, but for Chrome. But caniuse.com is really, really cool. I'd encourage everyone to always go to that when it's available. But Chrome Status is this kind of documentation platform that we maintain that roughly tells you when kind of file writer came in. So we're saying file writer APIs came in at M8, which is version 8. We're at version 14, 15 now. Blob Builder, that came in M8, and it tells you the APIs, when the API changed in M10. It's just a nice little way of kind of trying to keep track of some of the latest things that are going into Chrome. Let's jump into that. Sorry, I apologize. Who's seen HTML5 rocks? Yeah, good load number of people. Who's seen updates.html5rocks.com? No one. Okay, so basically HTML5 rocks is where we try and put our full articles and news, not news, sorry, full articles about how to use all the latest APIs, like how to use IndexedDB, how to use Canvas filters and all this type of stuff. Updates.html5 rocks is kind of cool things that we found which we think you should be interested in. We try and tweet them out as well, but it's just updates.html5rocks.com. And we tell you about new events. Paul Irish, who's going to come to the Dev Tools talk after this? Cool, well, I'll see you there. But Paul Irish is kind of one of the lead Chrome DevRel guys on DevTools, and he does videos, and we try and post all the kind of interesting news there. So I encourage everyone to kind of start looking at that. It's pretty cool. Chrome Frame, obviously, we kind of talk about this all the time, but a lot of the new features that we're putting onto the web platform aren't available on say, Internet Explorer 6, 7, and 8. You can actually use Chrome Frame. Chrome Frame, if they install it, is pretty much just automatically swapped out. It swaps the kind of default rendering engine just by the one meta tag or the HTML header. You don't have to do any, or the HTTP header, sorry. You don't have to do anything else to actually get the Chrome goodness inside of the browsers, or inside Internet Explorer at least. And this is our resources. So obviously we've got bleeding edge html5.appspot.com, which is this presentation. The code for this presentation. So the really cool thing about this demo is that obviously all the demo is done kind of in HTML5 and JavaScript. And it's done in line. So you'll be able to see how we started web intents and how we do all that type of stuff. All the code is available. webrtc.org is interesting. webintents.org. This is where all our documentation about web intents is. I encourage everyone, because I'm kind of one of the dudes who's kind of really passionate about this. We've also got a group on Google Groups. I encourage anyone who's building applications and they want to kind of start integrating API to join that group, because we want to hear your voice and we want to hear kind of how you plan to use the API, what doesn't work in the APIs, pretty much your complete opinions about kind of how you want to start communicating with applications and do the application service discovery as well. Yeah, so we've got HTML5 rocks, Chrome status, caniuse.com is absolutely awesome. It went down the other day. I'm pretty sure it's back up. And if you ever find any bugs in Chrome, make sure you submit them, new.crbug.com. Yeah, so that's the end of the presentation. I hope you enjoyed it. Yeah, like I said, we're looking for feedback about kind of this presentation, what you expected, what you didn't expect, you know, what we can do to improve it. Likewise, with any of the APIs, I'm really keen to hear your kind of complete feedback. Just before I finish, there is one final thing. I haven't got it anywhere. Damn. Yeah, so there's the hackathon competition thing that's happening soon. Keep your eyes open for it because obviously you can win some tickets to Google I/O. And, you know, yeah, they'll talk about it. I haven't got the link, and I apologize for that. So, but anyway, thank you very much. Yeah, it's been good speaking to you. If you have any questions, just shout them out. Catch me later. So, any questions at all, or? Yes.
Question regarding web intents.
Yep.
How did you build the list of available services? Does the user need to manually enter those?
No, so yeah, so the question is, how do we build a list of services in the web intents demo? So it's that intent tag. So when the browser detects the intent tag, it asks the user whether they want to install that application as a handler for that intent. And then the browser keeps track of that. So the way it actually works inside the shim is there's a little piece of JavaScript that looks for an intent tag, and then it'll do the hookup behind the scenes. So, yes?
This rendering needs to be to a page in the same domain?
No. No. So I believe Google Search uses it. They announced it a while ago. Is that the first link or whatever it is they try to pre-render it when they can. It doesn't have to be in the same domain.
That's kind of dangerous.
Yeah, I mean, potentially. It was turned off. I don't actually know why it's turned off at the moment. So yes?
I'd like to ask if you plan to support these advanced HTML5 features to Android, like audio processing, video processing, and like this.
I hope so. I mean, the whole idea behind most of these APIs that are in WebKit, so any browser that takes advantage of WebKit, you know, they can choose to support it or not. So if you look at the way you build WebKit, you can enable a whole load of features at the build, and then it's just a matter of Android guys doing that if they wanted to. I unfortunately don't know anything about the Android browser and what they plan or plan not to support. So, but once it's in WebKit, it's a whole lot easier for these devices to support them. Yes.
So inter-use API might not be widely accepted by other browsers.
So which?
All of them.
Yeah, I mean, they might not be. We want to try and get to the point where pretty much all the browsers support the majority of APIs, but at the moment, the way I look at it is where some people differentiate themselves, at least. Teams have different priorities as well, so the Internet Explorer team and the Mozilla team and our team will probably have different priorities about what we think is important on the web. But there for the new APIs, there's a whole kind of common standard that we've had, and we've got a pretty damn whole load of support across all the browsers for a lot of HTML5. It's just like, you know, who's going to support the WebRTC? Well, we are, Mozilla are, and Opera. The others, then it's a decision based off the types of applications and that each of these developers use. Each of the applications that developers build and the users want. And then that'll drive demand to get the other browsers to implement them as well. Cool. Anyone else? No? Cool. Well, thank you.